So I just read this from a big name in AI. Within 3 to 8 years, we will have a machine with general intelligence of an average human being. No, this is not a latest tweet from Elon Musk. It is a 1970 quote from Marvin Minsky, often considered to be father of artificial intelligence. In 2021, we often hear great predictions about AI, both related to specific applications and general power of machines over humans. The fact is, nobody really knows how the future will look, but the best way to develop an intuition for future is to study the past. I spent some time studying artificial intelligence history last year, and I have decided to make a series of videos to share that knowledge in a way that is accessible to professionals from many fields. So let's get on the journey.
A brief history of artificial intelligence. Artificial intelligence has taken the world by storm in the last few years by demonstrating computers can perform highly intellectual and creative tasks, as good as human experts and sometimes much better. Terms related to AI are being thrown around everywhere, and everyone from classroom to boardrooms is intrigued by the future potential of AI. There are varying views on the future of AI. Will it mark an exponential growth or bursting of a bubble? While linear present to future predictions will always be given by the pundits, leaders in their respective fields will benefit from having an eye to the past to develop a deep intuition, preparing them for the future ride. With this view, let us get on a journey to look at the history of artificial intelligence. The desire for automation has existed from early days. Aristotle hints on the idea in his book The Politics. Leonardo da Vinci designed a humanoid robot in late 15th century. In more modern times, German philosopher Gottfried Leibniz conceived the idea of a universal language to automate the process of reasoning that can resolve any philosophical disagreements automatically. However, it was only around the 1940s, with major developments in the electrical computers, that any attempts at mimicking human thinking began to look feasible. Around this time, English mathematician Alan Turing described what was called a universal machine. In the Turing machine, instructions to execute are provided on a strip as zeros and ones. A read-write module is used to read the instructions. The read instructions are sent to the logic unit for execution. The logic unit implements the operations, including changing instructions themselves or deciding which instructions to execute next. The final output is written back on the strip using the read-write module. Turing proved that given an infinitely long instruction strip, any computational task can be performed by this universal machine. This architecture forms the basis for most modern digital computers. As the architecture was being practically realized, Turing hypothesized if these are truly universal machines, they shall be able to mimic human thinking. In his famous 1950 paper, Computing Machinery and Intelligence, Turing proposes a test to determine if a machine can think. While the paper describes an imitation game, a simplified version of Turing Test is described as follows. If a human carries out a conversation with a machine and another human in different rooms and is not able to tell them apart, then the machine has passed the Turing test and can be considered to demonstrate intelligence. While several questions have been raised about the Turing test, it is still the most commonly accepted test of machine intelligence. The test itself requires a moment of reckoning. Firstly, Turing test calls for the presence of human observers to judge machine intelligence. A broader consequence of human assessment is that it will always be subjective and driven by perception of the times. This also leads to what is called AI effect. That refers to AI is whatever hasn't been done before. Secondly, the test requires the machine to imitate human behavior rather than exceed a set of performance goals. This raises a question of practical utility of intelligent machines. From an industrial point of view, we want machines that are flawless and ideally require no supervision or management. That is certainly not a human characteristic. In any case, with a theoretical proof that machines may achieve intelligent behavior, a growing understanding of how human brain functions through electrical impulses, and advances in electricity-based computers, the stage was set for the new field of artificial intelligence in 1950s. Next, we will see how the rapid growth in the field led to some extraordinary claims like New York Times publishing Development of an Electronic Brain in 1958.